So let's finish this up. So this one here, you recognize it, arctangent, and you recognize this, arcsine. Okay, so then we need to evaluate it between these, always plugging in the top number first. So arctangent of 1 plus arcsine of 1, and then I'm going to be subtracting arctangent of -1 and arcsine of -1. Okay, good thing we know these. Remember, both of these have to be restricted in this restricted angle. So arctangent of 1 is pi over 4, and arctangent of sine is pi over 2. I'm sorry, arcsine of 1. And so then in here, you know this is negative pi over 4, and then this gives me a negative pi over 2. So this subtraction sign carries through. So I get pi over 4 plus pi over 2 plus pi over 4 plus pi over 2. So be careful with all those negatives. So this one here, you need to make sure that you're taking the time to split it up. So I'm going to go slow because you want to make sure that the number stays in the denominator. So here we go. All right. So I'm going to cancel the x squared, so I just get the number 1/x over, sorry, 1/2, the number 1/2 times x. And this one here, I get the number 1/2 times 1 over x. And I'm going to leave it down there because I'm going to use the fact that this is ln for the antiderivative. This one here, if I cancel the 2's, I get a 1 over x squared, so I'm going to write that as x to the -2. And it's still between 1 and 2. Okay, so now I'm ready to take the antiderivative. 1/2 x squared over 2 minus 1/2, and this is ln of x. And then this would give me a minus x to the -1, right? Because you add 1 and put it over that same number. And then we evaluate it between 1 and 2. So plugging in 2 first. So I'd get 4 over 4 minus 1/2 ln of 2 minus 1/2, and then I'm going to plug in 1. So I get minus 1/4, and you know ln of 1 is 0, and then that would give me a minus a 1. And you could join some of those things together. So I want to make sure that only 1 over x that you say is ln. This is not, so 2 over root x is not 2 times ln of root x. Can't do that, okay? So this one we would rewrite. So x to the -1/2, and then I would just carry this, the number 3/4 times the 1 over x. So taking the antiderivative of this, you'd add 1, and over 1/2, or times 2, and then minus 3/4 ln of x, and then evaluate between 4 and 8. So I get 4 root 8 minus 3/4 ln of 8. And then I'm going to be subtracting off 4 root 4 minus 3/4 ln of 4. So there's not much simplifying that really can go on here. I mean, I guess I could play with this a little bit, right? So I could get 2 root 2, so that gives me 8 root 2 minus 3/4 ln of 8. And then this number here would just give me an 8. So I get a minus 8, right, because I got to distribute, and then a plus 3/4 ln of 4. That's a fine answer. So then we need to multiply this out, so be really careful. Exponents, right? So 0 and 1, so I have 3 x to the 1 times x to the 1/2. That gives me x to the 3/2. And then when I multiply this times this, the x's cancel. So I get a -6/5, right? Okay, so I'm going to take the antiderivative. So x to the 5/2 times 2/5. And then the antiderivative of a number, remember, is 6/5 x. And so then I plug in 0 and 1. So I get 6/5. And then plug in 1 here. And then minus 6/5. Oh my goodness, it equals 0. Okay, making sure that you know all the antiderivatives. Antiderivative is tangent, or secant squared is tangent. And then you got to keep it all in thetas, right? Everything is a d theta, all thetas. And then antiderivative of negative 2 sine is just a positive 2 cosine, right? Just remember, derivative of this has to equal that. And then I get another negative 3 theta, not x or t, right? Then plug in 0 and pi over 4. So I get, well, let me put it down here. So I'd have tangent of pi over 4 plus cosine of pi over 4 minus 3 times pi over 4. And then I'm going to subtract off 0. So let's be careful. Tangent of 0 is 0, but cosine of 0 is a 1, right? And then that will give you 0, 2. So I get a 1 plus 2 root 2 over 2 minus 3 pi over 4 minus a 2. And that's a fine answer.